I want to give an example where we're going to talk about unit conversion, changing cubic feet into cubic miles and centimeters into kilometers and things like that. But also, I want you to be able to do that using estimations. So you can do sort of some mental arithmetic to calculate ideas or calculate values. But also, I want you to be able to do it precisely if we have the exact values. And we're going to talk about this in some concrete examples, but also in kind of more abstract examples where we'll use unit conversions for lots of things. And you'll see those in class in some examples. But for today, I wanted to look at this map of the projected snowfall tomorrow and Monday. And my question is, if we took all of the snow in Ohio, how much snow is in this snowstorm? So if we took it all and mushed it into one huge big snowball, how big is it? Is it like 100 feet by 100 feet by 100 feet? Is it a mile by a mile by a mile? What if we smushed it into a ball, or we'll pretend it's a cube because that's easier to calculate? How big would it be? How big on a side? How much snow are we talking about? So I want to do it in three ways, getting more and more accurate as we estimate better and better. So, and that's something that I want us to talk about in class, how you can do rough and dirty estimates, then you can do a little bit more accurately, and if you have better data, you can do it even more accurately, and we'll do that in many instances. So let's just, without even a calculator, you can get a sense of how much snow. So first thing you might need to do is figure out what's the area of Ohio. Do we have any idea? So that's something that we could calculate, or we could look up. But just use your intuition to get a sense of it. How many square miles do you think Ohio is? Well, my intuition is, from Columbus, it takes me about an hour to drive to either boundary. Hour and a half to drive to either boundary. So let's say it's 100 miles from Columbus to the side and 100 miles to the Columbus to the other side. Let's say it's 200 miles across. That's not exact, that's not perfect, but it's close. And let's just pretend for now that Ohio is a nice perfect square, which it's not. But it'll give us a ballpark range. And for a lot of estimations, that's good enough. So let's say it's 200 miles across and 200 miles up and down. It's a nice perfect square. So the area of Ohio is that's 40,000 square miles. Square miles. And then we need to figure out how the depth of our snow. So we have the area of the base times the depth of the snow. That's going to be our volume. Area of the base times the height is a volume of a cube. Let's say the snow averaged about 6 inches. If you look at this map, this yellow orange thing is 6 to 8, 8 to 12 inches. The blue down here is 3 to 4. It's somewhere, let's say half a foot on average. So then what you can do, can you mentally calculate how big that is? 40,000 square miles times 6 inches. How many cubic feet, how many cubic miles, what units could you use to do that? Well, start converting units. 6 inches is half a foot, right? So what's 40,000 square miles wide area by half a foot deep? Well, how many feet are in a mile? It's 5,280 feet. So just for estimation, let's say it's 5,000. So half a foot is going to be 1/10,000th of a mile. So a foot is a 5,000th of a mile. So half a foot is a 10,000th of a mile. What's 40,000 times 1,000 or 10,000? 40,000 over 10,000 is about 4 miles cubed. Cubic miles, 4 cubic miles. And so we had, and we'll talk about the units a lot, we had square miles times miles. That's 3 factors of miles, length, width, and height, 3 dimensions. So we're going to have cubic miles. and it's about 4 cubic miles. So how big is 4 cubic miles? Well, think about it this way. 1 mile on a side, a mile by a mile by a mile, is 1 cubic mile. 2 miles by 2 miles by 2 miles is 8 cubic miles. That's 2 cubed. 2 cubed equals 8 cubic miles. And so our snowball, our snow cube, is in the middle of that. So we could figure out exactly what it is, but basically, let's say it's between 1 and 2. Let's say it's about 1.5. And so you could get a sense of, you know how wide a mile and a half is generally. You can kind of have an intuition for how big that is. A mile and a half by a mile and a half, and a mile and a half deep. That's a big snowball. But that gives you a sense. How could you do that more accurately? Well, a better is, and if you actually could look up some values, what is the actual exact area of Ohio? Well, I looked it up, and it's 40,860 square feet or square miles. So our estimate of 200 by 200 was really, really good, better than I expected. Let's say the average depth of snow is 5 inches. So we have a more precise thing there. Then those numbers aren't as nice. So doing the math mentally is going to be more awkward. Is not the mental math is going to be harder to do. So go ahead and use a calculator at that point. If the volume, and so the volume is again the area of the base times the height. But we want to change units. We want to do it with units. So I have square meters for my area, but I've got inches for my height. So how can I change those to feet, square feet, cubic, and feet to get cubic feet? Well, I can change square miles. In 1 mile, there's 5,280 feet. But I have to do that squared because there's 5,280 feet on the length and 5,280 feet on the width. So in the area, I've got to square that. So 40,860 times 5,280 squared will give me my area of the base in cubic feet. And then my height, I want to change that to feet as well. So I take my 5 inches times 1 foot is 12 inches. So that's a conversion factor. And I can multiply, and I multiply by 5 over 12. Use your calculator, multiply that all out. And actually on my calculator here, it showed something like 4.746 e to the 11. That just means that it's too big for your calculator to display, but that means there's 11 decimals over, the decimal was moved over 11 spaces. So if you see that, that's how you can write it out better. So that's a huge number of cubic feet. But that's not an intuitive number. If you tell me so that's million, billion, 400 billion cubic feet, I don't have any idea any intuition for how big that is. So how big is that? Well, what you can do is change it into more reasonable, more relatable units. So how do you change that into cubic miles, for instance? Well, you've got this enormous number of cubic feet. To change to cubic miles, we will, 1 mile is 5,280 feet. And so this time we'll have to divide by 5,280. But to get cubic feet, I have to divide by that cubed. And so it turns out it's 3.222 cubic miles. So how big is 3.22 cubic miles, right? Well, in that case, pretend we have X feet or M miles on a side. And we've got, it's also that tall and it's also that deep. So then you want to know X feet equals this number. So you take the cube root of that huge number. Or you can do M miles cubed. Miles times miles should be 3.22. So we're going to take the cube root, and that turns out to be 1.48. So I could then, doing all these precise calculations with my calculator, I could get that the width and the depth and the height of my snowball is about 1.5 miles, right? And so that's remarkably close to the estimate that we did without any real calculator, just kind of mental mathematics to solve that. But even if you have the more precise numbers, you can use that and then use your calculator to get more precise answers if you want to. How could you even be more precise? One more step, and this is a preview to how they do calculus. One of the ideas about calculus is to how to find volumes over something that's changing. The depth of the snow is not 5 inches all across Ohio. It's up and down, right? There's deeper snow and lower snow and all that. So in calculus, what they have you do is you divide it up into little pieces. So let's divide up Ohio into 20 mile by 20 mile by 20 mile squares, and then you can approximate the depth in each of those squares separately. So let's suppose we have just this one square that's close to Marion, and it's 20 miles by 20 miles, and let's say there it was 9 inches deep. I could calculate, like I did before, the volume of snow in that square block, 20 by 20 square mile block. Then I could do that for all of the other regions at their different depths. And in calculus, you have a formula for that. You can do this, or if you have a spreadsheet, you can have it do those approximations. And those are how you do more and more accurate approximations by breaking the region up into smaller little pieces, and your estimate is more accurate on each one of the little pieces than it is over the whole state. And so you add up all those squares, whatever they are, and I made up some numbers and got something around that. 566 billion cubic feet. Again, how big is that? Well, you do the same idea. I can change that into cubic miles by this conversion of units that we'll talk about. I have to divide by 1 mile. 1 mile divided by 500,280 feet, but I have to cube that because I want cubic feet. And that turns out to be 3.85 cubic miles, which is 1.56 miles on a side. Because 1.56 times 1.56 times 1.56, the length times width times height, gives me my 3.85 cubic miles. And so the nice thing about this is you can do estimations at various levels of accuracy, depending on kind of how important your accuracy is. In this case, it really isn't that important. I just want to have a ballpark idea of it's about 1.5 miles on each side. And so I can do mental arithmetic to solve that. I can do a slightly better if I can Google some values like the area of Ohio. I can do even better if I have lots of data and can divide up the state into lots of places and have more accurate answers in all those spots. So the more data you have, the more accurate information estimation you can get.